to R programming language. If you want to export that data sets into your computer, we can export. If you want to load your data sets into console also, I have discussed yesterday. Okay, and some if else conditions also I have discussed, but I don't know whether the people got this information or not. So today I will again explain the same if else conditions. Then we'll go for further simple data visualizations and exploratory data analysis (EDA). Okay, the basic step in data analysis we will do today with the data visualizations and EDA, exploratory data analysis. So before going to discuss these two concepts, I will give you a quick revision of these if-else conditions. See, yesterday I have written these statements. I'm not writing newly. So just I'm showing here. See, for example, x equal to 30. I'm working in the 31st line. So x equal to 30, x equal to 10, which means that so I'm creating an object which object that object is having the value is 10. So I have stored 10 value in x. Now condition if x value is less than or equal to 10, then if the condition is true, then this statement has to be print. So I have given the statement is print the given value is less than or equal to 15, as it is like our C programming language, or if any other programming language, the same condition here also it will work in a R programming language. But the print statement, what the statement you want to print, that should be in the double quotation. So I have given C double quotations that we have to remember. Okay, next, if this condition is false, that is else statement. So again open the parenthesis, then we can print one more statement that the given value is more than 15. Now, for example, I will run this one. See, first one, x equal to 10, yeah, executed. X equal to 10 executed. Now, if condition, if x is less than 10, print this one, else print this one. Now, once I complete this complete function, now I got the value is, the given value is less than or equal to 15. I hope you understand. It's a basic one. In general, normal programming language, how we will write the same code we can take for the R programming language also. And coming to the for loop condition, this little quite different from the other programming languages. Okay, for the for loop conditions, the command is for only, and within the for parenthesis we have to define. So what is the starting observation to ending observation, or how many times you want to loop, you want to iterate your statement. See, here I have taken I. It's a small, you can take any symbol also, any alphabet also. Just I have, for my understanding purpose, easily I have taken I, a small symbol I am defining from I. This I is a iterating. So how many times I have to iterate? That's why I'm taking I. If you want to take A, B, or whatever you want, you can take. So I in 1 to 100. So I'm defining that I want to iterate my values from 1 to 100 times. Okay. Now within the for loop condition, this is the statement I have given. Again, I have given some if condition. If I is less than 10, whenever the I from 1 to 10. So if I is less than 10, the print the statement is it is less than 10. Otherwise, print it is greater than 10. Okay. For example, I will run this one. You will understand. Yeah. For kind of executed. Now you can see this one. Almost this iteration is repeated 100 times. First 9 times you can see here, first 9 times you got the values less than 10. Why? Because 9 values, 1 2 3 4, like that, 9 values which are less than 10, and after that 10 onwards, 10 to 99, 100. So the statement is giving greater than 10. So this is the values we are getting. So like this we can use for loop conditions, and if you have your own conditions, then you can display here within this for condition. If you have your own any type of any own conditions, if you want to iterate, you can iterate this one. Okay, for example, I will calculate a simple for loop condition. We'll go for a basic, for example, I want to find the mean of the particular values, then you can use here. Or if you want to find the median, you can find. So what are the values, if you want to do, you can do it here, the for loop, for iteration purpose. If you want to iterate 100 times or 200 times, how many times you want, you can proceed. So here I have this one is a basic how the for loop conditions will write in the R programming language. So simply we can write I in 1 to like this up to however what the value you want, that we can take. So this is the things yesterday I want to finish this values. So today that's why I quickly finish this for loop conditions, if and for loop conditions. Now today I will go for the actual session of our third day. So third day I will take a new script here, R script. Yes, new script I'm taking. This is day 3. So today we'll discuss about the data visualizations and EDA. Exploratory data analysis, a basic step, a common step in any data analysis. Okay, for the data visualizations we have many graphs, right? Many diagrams. We have one dimensional diagrams, two dimensional diagrams, we have 3D diagrams, and if you have more than 3D, you can go for pairwise diagrams, like that. How to represent the data in a diagram representation, that we will learn. And after that, EDA, how we will calculate that, basic we will discuss. Okay, for example, for performing this data visualizations, let's go with any one data set which is available in built-in. So I don't have any own data sets. I'm choosing built-in data sets to explain to you people. If you have your own data, you can use that one. As of now, I will already I have used this one, data sets. I know we know, right? So how to calculate these data sets? I will close this one. For example, I want to see what are the data sets are available. Just giving data or just empty parentheses. Then if I run this one, so we will get in the next, this is the code. If I execute this one, I got these are the data sets. Now in this data set, let's go with any one data sets. Randomly we'll choose any one. For example, let us, in the last class we said air quality, right? Let us go with air quality only again. So we don't want to bother about more. Instead of wasting of time, we will go with air quality. Otherwise, many people will go with iris data set or mtcas data set. Like that, many people will go. So today we'll go with air quality data sets instead of starting. This iris, mtcas you can find if you search in anywhere. So they will explain with this, mainly with these two data sets. So today I will go with a basic data set. Then starting one data set, that is air quality. Okay, let's go with air quality. Head function will be useful to see the first 6 records of our data. Okay, and tail function, so which will be useful to see the last 6 records of data. Okay, so if I run this one, yeah, these are the first 6 records of my data. So let us say ozone, solar, wind, temperature, month, day. Okay, this is my data set I have. Okay, for example, now this data will go for the visualizations. And here we'll see the full data. Just I will check is.na. Is there any null values or not applicable values are available in my data, that we have to verify. Why? Because here see the air quality data sets I have chosen, right? So initially in the air quality, see first variable ozone, in the variable the fifth value is Na, not applicable. There are some missing values are there. So that we have to verify, because if we have missing values, no, so there may be a problem. Because of the data visualization, we cannot draw or we cannot do any further techniques. Data is missing, no. Okay, so there are two ways. One is we have to omit the data set, or say we'll omit these observations if the missing values are there. Otherwise we have to replace that missing values with a particular measure. Okay, generally in our statistics we are going with mean to replace the missing observations. Okay, first we'll see that is there any missing values in this version. So for a draw, for accessing the variables from the R, so I will attach the data. So attach air quality. This is I have already explained, right? Attach. What is the use of this attach? Attach command will be useful to attach your data sets to our console, so that we can extract directly the variables. Okay, instead of calling variables through the data set, always air quality dollar ozone, air quality dollar solar, like that. No need to extract through the data set name every time. So I have attached data. So with this, directly we can access the variables. Okay, now is.na, is there any null values in the data set? That's I will go. First, let us go with ozone. I will do one thing. I will copy this one, ozone variable, copy and paste it here. Could not find function is.na. Maybe this required any function, any package. Check it. Sorry, small nv, not capital N. Okay, fine. Ozone not found. We have attached data, right? Yes, see here, we have attached data, but we are not executed the data into our console. See, head function, I run this one. and after that I'm running is.na. But here I have written this attached function command, but not executed due to that way showing. So I will execute this one, run. Yeah, executed. Now I will go with is.na. Yeah, there are many are there. See, first one is false. False is nothing but no. The first observation is not missing. Second observation is not missing. Third one is not missing. Fourth one is not missing. But true. Yes, the value is missing. Okay. This values we have to replace. Okay. How to replace these values? Okay. We'll go with first. We'll see the data set. Ozone. Copy and paste here. uh, there are many n dot na values are there. So from this I will remove na values. Okay, how to remove? uh, we'll go with first one. We'll identify what is the position, what is the index of the uh, ozone values. So okay, which dot, which of ozone equal to na. No zeros. Ozone is not equal to na. Okay. Wait, which ozone? I'm identifying the first null values. Ozone. It is showing zero. Okay, fine. Ozone. Just I'm finding what is the index of that values. What happened to this one? Ozone. Just a minute. We are writing properly only, right? So just a minute. I'm trying to identify this one. Argument which is not logical. Yeah, fine, but it's correct only, right? Which ozone? Yeah. So here we have some missing values. Na is there, right? Is dot na also what? Let us take. I will store this value there. A. Now A is having these are the values. Now where A equal to false. Yeah, fine. This you see here. Here what I did, so is dot na. So this is a new thing is facing now I'm problem. Actually I thought directly we'll go with the data set does not have any null values. Okay, let's say this is also one of the tasks to us to complete. Okay, generally we'll get the missing values, right? So with that only we are facing this. Now we'll go this good only, or we will learn this one. See here, a ozone is a variable. This is having some missing values. Okay, so now what is the command to you identify the missing values? Is dot na. Yes. So in this is dot na, so ozone. What is that? So is there any null values or na values are available? Yes, there are some values are available. So if I run this a equal to is dot na, so I got this command is false, false, true, true. Okay. Which means that this function is having false, false, true, true values. Now which dot a equal to, instead of going for false, let us take true. It means that, so where is the null values that index will show. Okay, exactly this one. See, fifth value is missing, 10th value is missing, 25th value is missing, 26th value is missing, 27th value is missing. There are many values are missing. Okay, almost 33, 34, 35, 36, 37 values are missing. I will see what is the length of the data. len gth, so length of ozone. What is the use of this command? So length of ozone will be useful to see the number of observations are available in a particular variable. Okay, ozone. See, there are 150 observations are there. Among these 150 observations, there are almost 36 observations are missing. 37 observations are missing. That is a huge data is missing. Maybe the replace will give a problem. Okay, okay, no issues. For our for basic one, I will go with this variable. Okay, then I will go with this variable. We'll go. We can discuss about how to fill the missing values. Okay. Now see, these are the index positions. 5, 10, like that. All these index positions are the missing values. Now what I will do, I will store this. I will delete, and let us take missing index IND. So these are the mind. Let us say like this. Missing index values, M index values, and available index values, A index. Just I am writing something. Now here, the same command I will copy, paste. So here I will do false. Yeah, I'm doing manually instead of going for a quick comments. Yeah. So now what is this values? A index is nothing but. So in our O zone, so these are the observations, which means that the first observation, second observation, index values. So these are the observations are available. And here, so in M index, if I run this one, in M index, these are the values are missing values. Okay, positions. The fifth position is missing, 10th position is missing, 25th position is missing. Like that, these are the missing values. Now, what we have to do, we have to replace this missing values with some measure. For example, let us say basic one, I will go with the missing the values with the mean. Okay, so how to calculate mean? So what are the missing values are there in the data that we have to keep aside, and the remaining what are the available data we have. That available data we have to find the mean. Then that mean has to replace with the missing values. Okay. Now what are the values we have? Now missing index I am keeping aside. These are the available index, which means that so in this index the data is available. Now with this, what is the data set we have? Ozone, right? So ozone, sorry, variable. So ozone, in this ozone, so I will take AI index, which means that all available index values. What is this A index is tells? So A index is first one, second one, like that. So in ozone, these are the available values will be displayed here. Now if I run this one, see these are the original data which are available in the ozone. Okay, other than missing values. I removed missing values from the ozone variable. I hope you understand how I'm doing. So here, first of all, initially I have calculated is there null values are there or not. Okay, ozone. If I use this function, so it will create a logical function. One is yes or no. Yes is nothing but true. Now it's not NA. Now, no means false. You will get yes or false like that. How many observations are there? There are 153 observations are there. So 153 logical operations, yes or no will get. Now in this, if there is a true means yes, null values are available. If there is false means null values are not available. Now I have segregated that both separately. See, first one is which A equal to true. True is nothing but the null values are so true is nothing but here null values are missing. Here the missing values are available. Now false is nothing but the missing values are not there. So now I have separated this data into two ways. One is missing index positions, another one is available index positions. Now this available index positions I have taken into ozone index. Ozone within the square brackets I have taken available index values. Now this gives us the all available observations in the ozone. And if I take this one, copy, and if I paste here, instead of here, if I take M, and these are the M index, you can see this all null values I got. These are the null values which are available in the ozone, and these are the actual observations which are available in the ozone. Now what we have to do, find the mean of these available observations, and that mean value replace with this missing observations. That's it. Okay, first I will find the mean. How to find the mean in R programming language? A basic command, mean only. So mean of what is the data we have? This is the data set, right? Ozone available index. Copy this one and paste here. So what is the meaning of this one? So what are the available observations of ozone? For all the observations, I am finding the mean. Okay, I will calculate this one. Now see, this is 42.12. This is the available, this is the mean value for this ozone observations. Now this 42 you can replace with the all missing values. How to replace? So this value I will copy. Now let us take, I will store this mean value with the, so mean of available values. So let us take average. AVJ. So average. So I have find the mean for the available values. Now I will run this one. Yes, AVG I got. Now average is nothing but 42. Observe average value of the ozone. Yeah, 42. Now I have to replace this mean with the missing values, right? Where are the missing values? These are the missing values, right? So take this copy and paste here. Now this equal to find the AVG. Copy here. Now, what the meaning of this one? In the ozone, where these missing values are there, that missing values we are replacing with AVG. Now, if I run this one, so finally we got ozone, ozone. So data set is, see here, ozone data set is replaced with missing values. Now see here, this is the ozone data, original data. So 40 first observation, for 36 second observation, third observation 12, and fourth observation. See, fifth observation is missing. That is a mean value, right? 42.129. See here, 42.129. We replaced it, and this is 28. So original data, original. Again 42 replaced. So wherever the missing values are there, that missing values we replaced with the mean. I hope you understand. Simply what I did is nothing but first I have identified, I have performed the logical operator, that is dot na. Is there any null values are available, are there in the data? So this gives us true or false or true statements. So false is nothing but it is not missing. True means S is missing. Now what I did is I have segregated false separately, true separately observations. So through the using which operation, okay, which command. Now this command gives us what are the available index positions, what are the not available index positions. Okay. Now with using these index positions, I have divided the data from the ozone. That is ozone of available values, ozone of missing values. Now using this ozone available values, I have calculated the mean, that is average. That value I have stored in the AVG function object. Now this object taken I have taken and I have replaced the missing index position values with this AVG. Now what the values we got? All ozone values. So wherever the missing values are there, that missing values are replaced by AVG. Now this is the data set we have. See, this data set is having a lot of decimals, right? Around 1, 2, 3, 4, 5 decimals are there. Each and every observation have 5 decimals. Let's go with we'll round this decimals. Let us say I will take only 1 decimal or 2 decimals. So whenever you want to do decimals, if you want to reduce the decimals, we have to use the function round. Round is a command which will be useful to reduce or increase the decimal places of the value. Okay, so what is the value we have taken now? So ozone, copy and pasting here. So round of ozone 2 comma 2 decimals. If you give a number, how many decimals you want, you have to indicate here. Here I'm going to indicate 2. That is only 2 decimals I want for my data. Okay. Now see here, if I run this one, earlier it is showing 5 decimals, right? You see here 5 decimals are there, but here 2 decimals are there. You can take 1 decimals also. You can keep 1, you can keep 0, no decimals, the rounded figure values. Like that you can use this function round. Now I will store this data in any one object. Let us take new ozone. New ozone equal to round of this one. Now this is a new observation, a new variable I have created without missing values. Say new ozone. Just right, and this is the original data. Sorry, data which doesn't have any missing values. I replace the missing values. I hope you understand. Now this is the original one variable we got. Now with this variable we can go for the plotting. Like this we can do for the missing observations. We can replace. If you are facing any type of little problem with the missing values of code here, then you can do one thing. Take this data to export this data to Excel. Okay, in the Excel it is very easy, right? Because of in the Excel we have filter options. So with the filter directly we can create a filters. In the filters we can choose NA values. So you will get the list of NA values. So in the place of NA, so you can gather the remaining values mean and replace. So data pre-processing mostly we can do in the Excel itself. So we don't want to bother about R programming, R codes. Why? Because the ultimate goal is that you have to do the data analysis. That's it. We can use any programming language, anything. Okay. There is no rule that you have to R programming, you have to use Python like that. So why I'm teaching is I'm teaching here both how to do in the R programming language. But if you are facing any type of issue, these comments, I got little doubts or a little problem with these comments, sir. I'm not probably how to manage these missing observations or how to do pre-processing. We can go with Excel, no issues. Easily we can do there also. Okay, but if the data is very well perfect and R is very best. So for doing data analysis further, okay. Even pre-processing also is good, but if you have any beginners here, they will think that they might have feel that, oh, it is very tough. Okay, don't feel like that. It's easy if based on practice you will get. However, no, sir, we'll do some pre-processing in the Excel itself. You can go with. So openly, I'm saying this one. There is no rule that you have to do pre-processing in our programming language only. Okay, why? Because this much lines, writing of this much lines of code, instead of writing this much lines directly, we can do missing values in the Excel. Right? Am I right? So that's easy. Okay. And you can say, sir, then why we will go with the data analysis with Excel only? Why we are teaching R? So all data techniques will not are not available in Excel. Okay, R is the best one, which will be beautiful techniques. But one thing we have to understand the codes. Whenever you are facing a problem with the code, then I'm saying okay. But don't think that Excel is better than the R. Fine. So this is the data set I have. Now, for example, this is a continuous data, right? Data is continuous. Okay, right? Because Ozone, they have taken some PPV measures. Yesterday we saw this one. So data is continuous. Generally, we have different plots. So before going to draw the plots or diagram representations of the data or visualization of the data, so we have to decide, we have to understand what is the data type. In general statistics we have two different types of variables. There is two different types of data types. One is continuous data, another one is discrete data. This majorly we have to understand. If the data is discrete, we have to follow some specific diagrams. If the data is continuous, then we have to follow some specific diagrams that we have to remember in our minds. For example, if the data is discrete, then we can go for bar plots, pie chart, multiple bar diagrams. Like that we can go if we have data is discrete. If the data is continuous, then we can go for histogram, box plot. Like that we can do. Okay, and if your data is two-dimensional data, then we have to go for scatter diagram. If the data is more than two dimensions, we are going for matrix where data. If the data is three dimensions, we are going 3D plots. Like that, specifically we have to choose what type of diagram we have to draw. Okay, blindly don't draw diagrams without understanding the data type. Okay, so see what type of variable, whether it is a discrete variable or categorical variable or continuous variable. Like that, check the data variable type. Okay, then only proceed for the diagram representations. Okay. Fine. uh, okay, first we'll draw a simple bar diagram. Okay, here onwards we'll go with basic diagrams visualization. Let us take bar plot. Let us say bar diagram. Hmm. For drawing the bar diagram, so generally this bar diagram will draw for the discrete data, right? Okay, we'll see the data set. Any discrete data set is discrete variables are available on. So head of what is the data set we have taken? Air quality, right? Yeah. Any discrete data we have here. Month is discrete, 555 like that, and day is also discrete. uh, Temperature is continuous, wind is continuous, and solar is having some missing values. Ozone is also having missing values. So whether we replace the missing values here, either we can take this data or we can go further. uh, we'll go with month, but observations are 153, right? So we'll get a big one. We have to do frequency table for that. Otherwise I will do one thing. Quickly I will show you. Instead of doing the frequency table, Uh, for drawing continuous data sets, we'll take this data set. As of basically to draw bar diagrams, I will I will generate a simple data. You will easily understand. Let us take instead of taking this data set, I will generate a small data set. So I will draw. Otherwise, so we can draw this month and day also in the bar diagram. But we need to prepare a frequency table. Again, you will think, sir, this is the lines we are not understanding. Again, maybe the getting confused. So again coding means it will take a lot of time. I mean, it will be again you are saying that this much lines of codes you have to draw. Like that, you may feel discomfortable. Okay, I will show you some small things why we have to worry about it. Let us take I have some data. Data is, for example, let us take population. Simply we'll go with the population. So let us take population. Just I have created one a variable population. So this is having, let us take, I will take only five countries population. Let us take India 121 crores, and China let us take 150 crores, and then USA let us say 50 crores, and then some Pakistan will have, let us take 40 crores. The population I am taking, just four values I'm taking. And country, let us take, I have taken one more variable, country. So it is like a string, right? I mean a character data type. So we have to give in double quotation. First one is India, and the second one is China, and third one is let us take USA, and fourth one is, let us take Pakistan. Let us say Pak. Okay, these are just four variables I have taken, four observations I have taken in a particular variable. Now you see, this is the data is discrete, countable data, right? Again, do you want any expression about discrete and continuous? Simply, discrete data is nothing but countable data. Okay, the number of students in the college, the number of students in the class, or the number of students are attended, and let's say if it is a count, then we can call it discrete data. If it is uncountably infinite number of values, is nothing but continuous random variables. We know this, right? The basic difference between discrete and random variables and continuous random variables. Okay, like that. Okay, here the data is count, right? Discrete. Okay, 121 crores, 150 crores, 50 crores, 40 crores is the data is discrete. So whenever we have a discrete data, then we are going with a bar diagram, a multiple bar diagram, scatter diagram, sorry, subdivided bar diagram, or pie charts, like that we can draw. So basically I'm drawing bar diagram here. How to draw bar diagram? Simple bar plot. Yeah, so code is very simple. Bar diagram is nothing but bar plot. So what is the data set we have? What is the variable? Population, right? Population, that's it. So just click this one. First we run this one, country executed, and population is executed, and then bar plot. See this one. Here you can see this bar plot simply. So first one is India, China, USA, and Pakistan. So you can give the colors also, or you can represent this country also here. For example, let us take, so in this bar plot, I want, what is this bar tells us. For example, if you want to give, okay, let us say we'll go with we'll give some the names of this blob bar diagrams. So if you want to give additionally some names of these bar diagrams, we have to use this argument, that is names dot arg. Yeah, we got. See, names dot arg is nothing but names arguments. I mean, what is this name of these arguments? Okay. Population is the data, original data, what we have taken here, and then what is the values represents. Okay. Now values is represent the country, right? So names dot argument equal to country. Now if I run this one, and now see below, India, China, USA, Pakistan. If you want to give a title of your plot, everywhere in our programming language, for any plot, if you want to give a title, then you can use main function. So main equal to, so title of your plot. Let us say this is India country wise population. So a population across countries. The country wise population. Country wise population. Simply I have given one title for my plot. So if you want to give a title in our programming language for any plot, so sometimes we may change these arguments. Okay, but this main is a function which will be useful to give the title for your plots in our programming language. Okay, now if I run this one, see above here, country wise population. So I got this population values. Like this we can draw. If sometimes you will ask colors, no, many people will ask the colors. Okay, let us say I will give some colors. Wherever we want to give the arguments, you can give arguments. There is no rule that first you have to give the data here, then we have to go for names that are argument, then we have to go for main, then we have to give color. There is no like that. First value will be the data always. Remember, in the function, first value will be the data. Remaining whatever you want, you can take. Let us say color. Let us say color. I will take. How many graphs are there? How many bars are there? 1, 2, 3, 4 are there, right? Let's will give 4 colors. C of more than one value. I'm using concatenation. Let us say first one is red. Yeah, it displays red, and the second one is, let us say, blue. If the color is available, if you type that word, automatically that word will change to corresponding color. If the color is not available, it will not change. Okay, let us say yellow, and then the last one, let us take green. Yeah, if I run this one, yeah, now we got this one. So like this beautiful way we can design our graphs. So this is bar diagram. Okay, you can answer, sir. Yes, you have created a bar diagram. Sir, how to take this bar diagram to my computer if you want to export this one? Here you can see this option, export. Otherwise, you can zoom. Yeah, first this one I will see. You can zoom like this. You can easily, clearly, we can see this. What is the x-axis? What is the how the values are plotted? Okay. If you want to export your charts to your system, then go here option export. Click this one. It will ask two ways. One is if you want to export your diagram as an image or PDF, or you want to copy to clipboard. Anything you can do. If you copy clipboard and then you can paste anywhere wherever you want. Otherwise, if you want to save your image as a PDF, you can save. Otherwise, directly you want a PNG format, that is image format, you can go. For example, let us take I will go with the image format. Then it will ask where you want to save your image. You can see give the directory. Okay, wherever you want. For example, I want to store my image. Let us say in the CSR or college or programming. Here I want to store in the FDP. I want to store my image. Yes, this is I have given directory. See the directory file path came here. Now, what is the name of this plot? Let us say first plot I have created. Let us say bar plot. Bar plot. You can give the name of the file. And if you want to change this width height also, we can change. As of now, I'm not going to change. And then I will see this one. View plot after saving. If you want, you can view. Otherwise, no issues. A file name I have given bar. Next, if how you want to save your file. Either you want to save with a PNG format, or JPG format, or BMP, some EPS formats. Many, if you any researchers are here, so many journals they will ask your images into EPS format. Okay, so generally what we will do, we have to take the help of online. So in online we will connect PNG to how to convert PNG to EPS or convert JPG to PNG. Like that we will search, right? So it does not require directly we can save your images with the EPS or PNG or PDF. Okay, let us say I will go with a small JPG. Okay. Okay, then I will going for save. I will do. I want to visualize once the plot is saved. Okay, save. Yeah, once I save this one, see my automatically the image has been viewed. So like this easily we can export our diet charts. This is one diagram. Okay, and now for example let us say for the same diagram we will draw pie chart also. Okay, why? Because this is a discrete data, right? So same I will draw pie chart also. Let us say pie chart, pie diagram. I'm giving some commenting pie diagram. Now here, let us say same data will take. Why we want to create a new data? So already we have a country-wise population, right? If you want to draw pie diagram, just go with pie. Okay, pie of first always give the data set. Okay, that is population. Now whatever you want, you can copy. For example, let us say I will copy the color, same colors. So from here to here, and I will change this all title also. Let us say copy this one, Control C, and I will paste here. Yeah, so same I have copied and pasted in the pie diagram. But here one thing we have to change. What is that? Is that this we have to change names dot argument. Why? Because in the pie chart we will not call as a arguments this one or names. We will call it as a label. Okay, so that we have to change. This should be labels. We will call it as a labels. Okay, labels. Ah, labels within the parentheses we have to give that country. Labels equal to country, right? Actually labels is fine. Labels equal to country. I run this one. Yeah, it is asking some plus symbol here. That is we missed some parentheses somewhere. Where we missed any parentheses we missed? No, right? It is asking well, again is showing some code is not completed. It is showing continuously. What's the problem? It's continuously showing. Somewhere we missed some parentheses. That's why the code is continuously is asking plus symbol. Okay, I will rectify this one. Population yellow, labels equal to country, comma main country-wise population. Fine, right? What happened? Yes, we got now. It's showing unexpected symbol pie diagram population color equal to red. Correct, only right? What's this? We'll do one thing. I will write again code, maybe some copy paste issues. Pie diagram within the bracket. So population. First we'll draw the diagram, then we'll go for one by one argument. So pie diagram population. Yeah. So now I got this pie diagram, right? See, this is a one pie diagram. I got some 1, 2, 1, 4, 3 like that. So there is no any proper meaning of this 1, 2, 3, 4. So I will change one by one. Let us take population color equal to. Let us take. I will copy same thing from here to here. Yeah, I got the colors also. Now I will give labels instead of labels here. I will give main, first main. So main equal to within double quotations. What is the main? Let us say population, country-wise population. Yeah. Then again, first we'll run this one. Yeah, I got the title also. So main, and now I will give the labels. Labels equal to labels, which is equal to, let us say, what are the labels? Country. Yeah, now we got. Earlier the same code we have written, but why it is showing error? Maybe some here we
Sir,
forget double quotation.
Shiva
Yes,
sir,
sir.
yes sir, that is only. Yeah, I just want to say that
Double
inverted
quotation,
comma
right?
is missed. Yes, yes,
Yeah,
yes.
yeah, yeah. Thank you, sir. I
Okay.
copy paste. No, maybe that one.
Yeah, that was
Thank you
missed.
so much, sir.
Right.
Yeah, that's why I have written code slowly one by one. Now see, sir, country we have given. Okay, labels equal to country. This is good, right, to represent the data in pie diagram. And some people will ask, sir, here the country-wise data is given. China, India, Pakistan, USA. Can you see the what is the percentage of this India sharing in this pie diagram, or China? What is the percentage sharing? Okay, if you want to show the percentage also, we can show. Earlier here also we can show where the dog graphs. See these options we can go back. What are the plots we have drawn earlier? Okay, I'm going back. Here also we can show the percentages. Okay, here first I will show you here. Uh, Everything is same. Command is same only. You can run. Just I will show you here for this India all these things. What is the percentage? Okay, to show that one, calculate the percentages first. What is the population, right? So this is the population. We'll calculate the percentage of the for this population country wise. Okay, this is nothing but first we have to calculate the percentage, right? Let us take P or C, some object I'm creating. Percentage I will get to calculate. So total will be 100% is this one. So among this 100%, we have to calculate what is the sharing of 121, 150, 50, 40. Okay, let's go with we'll take the sum of. I will do one thing. What is the country-wise population? This one, right? Take this population, okay, and paste here. Population divided by sum of population, which is whole multiplied by 100. That is generally percentage, right? Generally, you will calculate 360 degrees. What is the sharing percentage? Okay, I don't want to that much complicated. Just I will go with small basic percentages. What is the percentage generally? How will calculate? So the uptake of the value divided by total value into 100. Same thing I did. So percentage PRC some object I have created. Now here the population we have. What the values I got 121, 150, 50, all values will consider here, and they divided by their sum of the population, all values sum. Okay, this value sum. Now population value, first value divided by sum, second value divided by sum, third value divided by sum, like that all the values divided by sum with multiplied by 100, you will get all percentages. If you want, verify this one. Yes, I executed this one. Now here I will see what is PRC. What the values? See here, 33% first one. What is India? Next 41% of China, 33%, 11%. We'll do one thing. will round this figure. Okay. I will write here only, or you will get confused. Okay, let us take percentage. This time I will round this ROUND. So I don't want to these many decimals to represent in this plot. I want only one or two decimals I want to represent. Let us say I want to represent in a one decimal. That is fine. That is round off. Again, the PRC values I have stored, right? The same values I have taken PRC, comma, just one decimal. I just now I showed know how to take this what is the use of this round function. So to reduce the dimension now decimals or to increase the decimals, we can use this one. Okay, this one is fine. Now you see what is the PRC values we have. Yeah, say P percentage values we have only one decimals. Now go with the new labels. Let us say these are the labels here I have given, right? Where the code given labels equal to country. No, in place of this country, I will create a new label. Let us take new, let us say underscore country. New country I want to display. How I want to display? So first let me think, let me imagine first how what the how I have to represent here. First India is there, no? India in the bracket beside in the brackets I want what is the percentage, then percentage the percentage I want here. Okay, there. So what I'm doing, I'm merging some text, right? First the country name, then the percentage values. So if you want to merge or if you want to add two string values or two values generally, so in our programming language we have to use paste option. Okay, use this one, paste. So just I'm pasting two values together. Okay, that's it. And now what the first one will be country. Okay, country, what is the country means? Names India, China, USA, like that. First I want to take country. Okay, yes, paste country. Now give comma. Next, after the country, what I want to paste, I want to paste this percentage, right? Directly instead of pasting the PRC, just let us take, I want to paste in the brackets. Okay, let us take within the double quotation, I will open one parenthesis. Okay, then comma. After this one I want percentage values, then after this one I want within the double quotation the percentage symbol, then close bracket. What is this meaning is nothing but, so I am pasting first country values, that is India, China, Pakistan, USA, like that. And then I want to get one open parenthesis. So parenthesis is nothing but in our programming language it is a function, right? So it will treat, if you are not giving within double quotation, no, it will give error. Why? Because see, these are the functions. Whenever you are opening parenthesis, closing parenthesis, it treat as a function. So that function should be should not take as it like this. That's why we are taking in double quotation. Now it treat as a one value, that is one name or one value, like that. Now with this one I am pasting, and after that PRC values I have to paste. If it is country, first country, then the corresponding PRC value has to paste here. Next, after that again I want to do this one, that is percentage. I want to the symbol I want percentage, then close. Percentage is also one operator. Okay, but we cannot access directly without giving, instead of without giving double quotations. If you give a double quotation, that will treat as a one variable or sorry one name. Okay, and that's why I have given double quotation. Now double quotation percentage, then close parenthesis. Now if I run this one, I will run this one. Now in place of labels, labels here, right? New countries, right? Instead of new country, we have created a new one, right? Remove this one. New country, that is new underscore country. So same labels only. Earlier in this is new country I'm giving. Earlier I have given this is as a country as a labels, India, China, Pakistan. Now this is the new labels I'm giving. That's why just I have created one object, new country. The same thing I have copied and I pasted here. Okay, now if I run this one, and now see here, I will zoom it. Yeah, see this one. Now it's beautiful, right? India 33.5%. See, parenthesis 33.5, the PRC value, a percentage value, then symbol, close parenthesis. This is created by paste option. First I want country, then corresponding percentage. Like this we can create. Same comments we can use for a bar diagram also. No issues. This is the way we can represent our diagrams in R programming language. Okay, so so for initially for the beginners you may feel that sir this much coding we have to do, why sir like that you may think. But sir once you practice, no, it will be the very easily you can do many things, you can easily perform. Okay. Yeah, fine. So this is generally we have created bar diagram and pie chart for the discrete data. Let's go with this simple. Let us go. I want some matrix. Let us say some multiple bar diagrams I want. Here generally I calculate bar diagram only. If you want multiple bar diagrams, then again we have to go for matrix data. Let us simply, I will show you. Then I will jump into my two-dimensional diagrams or any scalar if you have condensed data, how to show the data diagrams. I will show you. Multiple bar diagrams also will finish. Let us take, I will create one data. Let us take D, multiple bar diagrams, MB, D, multiple bar diagrams. First, create data should be in a matrix form. Whenever you want to draw multiple bar diagrams, the data should be in matrix form. Okay, let us take here. I will give some commenting. Multiple bar diagrams. Bar diagrams. Let us take data. I will give matrix of. Let us take one small matrix I will create. So yesterday I show first day I shown right how to create a matrix. Let us take 1, 2, 3, 4, 5, 6. So let us take 7, 8, 9. So your data should be in a matrix form. Then only it is possible to draw matrix scalar diagram. Okay. Let us say 3 rows and 3 columns. This is my matrix I have created. Let us say this one. Simple bar plot MBD. See this one. We got bar diagram. First one is 3 by 3 matrix, no? So 1, 2, 3. So each is divided by again 3 rows. I mean 3 is subdivided. Okay, this is subdivided actually. So first one is 1, 2, 3. So this is one area, first one, and this is second and 3. Totally this 1 plus 2 plus 3, this will be 5. Next, let us say 6. 1 plus 2 plus 3 equal to 6. Okay. Next, same thing. Second one is 4, 5, 6. This is fourth area, and this is fifth space, and this 6 completely 4, 5, 6. What you will get 15. So area is 15. These some subdivide bar diagrams. You can give colors. Same names dot argument equal to any. You can give the names of these diagrams, or you can add the colors or whatever you want you do. And now, sir, I want this data into multiple bar diagrams, which means that the bar should be beside. Okay, if you want that one, so just bar plot MBD beside equal to true. Okay, beside not a graphical parameter. Type of mistake. Yes. See this one. Earlier, this is subdivided bar diagram. So in the same bar, we have divided the data into spaces. I mean, in small boxes. Okay, bars, and this will be the multiple bar diagrams. So beside 1, 2, 3, 4, 5, 6, 7, 8, 9. You see this matrix, you will understand. If I run this one, what happened? See here. MBD. So 1, 2, 3. So this all are say first 1, 2, 3. This will belongs to one data variable, and this belongs to second variable, and this belongs to third variable. Okay, you can do one thing. Let us say this is imports doing by the countries. Let us say India, Pakistan, and then some China, and year, first year, second year, third year. Give the values here. Here, the second in the first year, second and third year, what is the China exports? In the third year, in the Pakistan, what is the exports in the first year, second year, third year? Like that, you can represent your data in a matrix form. That is, data dot frame should be there. So that with that matrix form, then you can represent your multiple bar diagrams easily. So in place of this data, you can give it your own data. Okay, quickly I have shown this one instead of showing completely writing all the data points and then visualizing. Same, sir. So code is same, sir, and then inside what are the arguments also giving is same. Just data only will change. See the bar plot I have used earlier for drawing the normal bar diagram. Same code bar plot, but inside the data, how the data is there, the corresponding plots will display. If you are not giving this argument beside equal to true, then it will come subdivided bar diagram. If you are giving beside equal to true, the bars will come in side by side. Okay, and same colors you can use, main you can use, whatever you want you can use. I will show you one thing also. So here color equal to sometimes you may ask, sir, here see red, blue, yellow, green. There 5 bars are available. I mean, I have 5 data points. These 5 data points are represented in the bar wise. I have given 5 colors. Let us say, sir, I have many bars. I don't know how to indicate, or I don't know what are the colors are available. Is there a random way to give a randomly the colors for the bars? Yes, we know rainbow, right? there are 7 colors and more than 7, or sometimes we'll get, right, rainbow. Generally, basic people will say 7 colors in the rainbow, and then by merging 1 or 2 colors, we'll get a new colors. So you can use that code rainbow. This we can use the rainbow option. Rainbow of what is the data we have? How many graphs we have? 1, 2, 3. This is having 3, 3, 9, right? Just give number 9. Rainbow 9. See here, 9 different colors we got. Otherwise, if you want to give only 3 colors rainbow, you can use a rainbow of 3. Only 3. See, red, 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 first value bar, and green, 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 and blue, blue. You can utilize this option, sir. Rainbow. This will randomly create some colors. We don't want to remember the colors also. If we have, let us say, 10 values are there, and these 10 values you are representing in 10 bars, or in a pie chart 10 areas you are dividing. And if you don't know, remember the colors, maximum we know, right? As I can remember more, maximum 6 to 7 colors. More than that we cannot remember. Okay, many people they will remember, but some people they cannot understand, they cannot remember the colors also, right? They cannot recognize. So in that situations, we can go this option rainbow. Using this function, we can directly give the colors for that one. Yeah, fine. So these are the things I want to convey here. And then now I will go for the, this is the discrete data. Whenever we have data is in discrete form, then we will draw these diagrams. And whenever the data is continuous, mainly statisticians people will use histogram. That is very, very important. I will let you know what is the benefit and what is the main advantage of this histogram. Okay, now I'm going for a continuous data histogram. Okay, for this histogram, I will use the original data. Okay, instead of creating data. Why? Because histogram is a continuous. It required more number of observations, right? That's why I'm taking this original data. Let us take head air quality. Just go with the wind speed, or temperature, or ozone. But ozone is having null values. We have omitted also. We have replaced that null values. We can take that variable original. Here I have created one value, right? What is that? New ozone. You can take this variable as a one continuous random variable, or solar is also we have to replace again. Does not require no focus on this. Wind you can take, or temperature you can take. Okay. Let's go with any one variable. Let's go with temperature will take, or you can take wind also. First I will draw histogram here, then I will explain. See, histogram. If you want to draw the histogram in R programming language, just code is hist, H-I-S-T, and what is the variable? Temperature, right? Temp. I will tell you what is the main advantage of this histogram in R programming language. Then I will display this one. Generally, for any statisticians, or if you want to do the data analysis, especially whenever we are using statistical techniques, most of these statistical techniques are two different parts are there. One is parametric approach, other one is non-parametric approach. Parametric statistical test we will call, or non-parametric statistical test we will call. Generally you might have listened this word. Statistical tests are two different types. One is parametric, another one is non-parametric. So parametric is nothing but there is some distribution assumption. If you want to perform, let us say t-test, if you want to perform ANOVA, if you want to perform, generally if you want to perform parametric test, there is some distributional assumption. And if you don't have any distributional assumption, or you are free from the distribution, then you are going for non-parametric test. Am I right? So non-parametric statistical test. Now, most of the times, most of the peoples will choose the parametric test. Why? Because the parametric test will give you beautiful results. But this parametric test, if you want to perform, then you need assumptions. Your techniques should satisfy some assumptions. Without assumptions, your techniques parametric test may not be possible to give a better results. Now, among these assumptions, different techniques have different assumptions. We have to follow particular assumptions for every test. Now, among all the assumptions, one of the main assumption is that data should follow normality. These are one of the biggest assumption in our statistics to perform a parametric test for your data analysis. One main assumption is always you have to assume data is following normality. Now, if you want to check whether the data is following normal or not, so the graphically it is one of the best technique to identify the normality, that is histogram. Using histogram, we can identify that whether the data is normally followed or normally distributed or not, that we can decide. If the data is not normal, is also we can identify using histogram. In case this is graphically, with using some graphs, we can identify the data is following normal distribution or not. No, sir, I'm not clear about the diagrams, how to see the normality. If is there any other alternative technique to check numerically? Numerical proof means yes, in our programming language or in statistics, we have numerical tests also. That also I will teach you. Okay, basically first we'll go with this histogram and we'll see whether the data is normally distributed or not. Okay, normally distributed is nothing but data is exactly bell shape. It's a normal curve will be there, that I will show you whether we will get normality or not. Histogram of temperature, I'm running this one. Yeah, oh good, greatness. See this one, data is looks like it's normal. See, the we can take like this normality as is some normal curve is there. Yeah, it's somewhat is indicating that normality. We'll see this one. See, for example, I have drawn here, right? Let us take, I will draw some density also on this, whether we'll get a smooth density or not. Density of temperature, TEMP. So this I have to plot as a line wise, right? Let us take lines of density. Ah, okay, we'll give color equal with the double quotation red color. Ah, yeah, you can see here histogram I have drawn lines of density. I'm drawing the density of my temperature variable. Color I have given red. You can see here, observe that the red color is coming, but actually this is not density, right? The density should be touches to the peak points, right? For that, see the y-axis you have frequency, no, that you have to change. Yeah, comma. So instead of this frequency, I'm drawing density, no, change that into density, that is in histogram probability equal to true. Keep this argument, one argument to change your y-axis. Okay, see here, this values I have y-axis, histogram probability equal to true. I will run this one. Yeah, once I run this one, see your previous one, this is a plot. There is a histogram, same histogram only, but y-axis will take as a density values. Okay. Now if I go here, it is density is changing. Now if I draw the lines, this is C. Yeah, it's looking normal only, right? Exactly, bell shape is there. One left side little skew is there. However, it's showing approximately it is normal distribution. So this we can identify using histogram, whether the data is following normal or not. Easily we can identify. What is normality? And many people will ask, sir, you are saying normality. What is this normality or normal distribution? Many people will know this one. If you know also, I don't know. Normal distribution is nothing but simply if you want to convey in a data, around 68% of observations will close to the mean, median, mode are all equal is a property of a normal distribution. Simply you understand normal distribution is nothing but it is exactly bell shape, and in the data 68% or above the data points are close to the mean, and less observations are fall at the tail ends, either left side and right side at almost equal, they have to fall. Okay, 68% observations should fall near to the mean, and rest of the observations will fall at the tail ends. Okay, this 68% also should be in the one standard deviation. It's the range from -1 to +1. Okay, it is built. So let us simply we can take the height. Height will follow normal distribution generally. If I take the, for example, any class, if I take the what is the height of this data, height of the students in a particular class, means almost all are belongs to same age group. So maybe their heights are almost similar. If I take the average height, then most of the students' height will be close to the average value only. Why? Because they are belong to same age group, so most of the candidates will have same height, and very less number of students have low height and very high height. Okay, the data is normally distributed. Most of the students have their height will be close to the average height, and the rest of the very less candidates are fall at the tail ends. So this is one of the best example for normal distribution. So the data is always should be like that. So because of with this property, many statistical techniques will work. That's why we need to check the data, whether the data is following normal distribution or not. Okay, now I have seen that the data is almost looks like normal distribution. Yeah, very great. Okay. Again, sir, if you want to give the color for this one, you can give the color COL. If you want to change this, by default it is coming histogram of temperature. If you want to change, use this argument main equal temperature, and you can change the labels also, x-axis labels, y-axis labels. If you want to change, you can change using xlab. That is also I will show you. uh, I will remove this one, probability does not require. Simply I will show you xlab. X lab is nothing but labels. What is the X labels? Okay. Let us take, I here temperature is there, right? Let us say I will give full form temperature. Yeah, this is the full form of X label, temperature, and comma Y label, that is Y lab. Y lab equal, let us say Y label is frequency. No, simply I will give frequency. Frequency within the bracket F I will give, and then first we'll run this one. Now see, x-axis, y-axis labels are changed, and you can change the limits also. Here 60, 70, 80, 90 are there. No, you can change the x lim, y lim using options. So let us take x lim. You can give wherever we want, sir. No issues. X lim. Let us say there are two limits, right? X limits. X limits are the X limits. Okay. Let us say X limits are 42. Let us take 120 X lim. See, X limits are changed 40 to 120. If you want to change Y limits, you can use Y lim. Like that, we can use the many arguments. Okay. X lim is not good actually because of the graph comes very lim. Okay, no issues. Like this, we can use many arguments, sir. See, X lim, Y lab. X lab is nothing but labels. Lim is nothing but limits. You can go for Y limits also. It will change the Y limits. Okay. Yeah, fine. And if you want to give color also, you can give color equal to some. Let us say this time we'll go for blue. Yeah, blue color we have given. Okay, if you want to do temperature and density curve also, let us take, again I will go with the probability I equal to, let us take probability equal to true. So I got this density values. Now we can see this density curve. I will change this layer. X lim is not good. 52, let us say 100 only I will follow. Yeah, somewhat good. Now I will draw this line densities. Yeah, a beautiful density is coming, but the density width is not much. No, very lean curve is got, right? Let us say if I want to change the size of that line, then we have to use LWD, line width. All are with usual words only, sir, that you have to easily can remember. No need to by heart. See, LWD, line width. I have drawn here one line. The line is very lean, not that much thickness. Okay, I want to draw the very thickness, then you can increase the line width. No, that's with LWD. So let us say LWD line width, randomly I will give a number. Line width is very 5, size is 5. Yeah, see, you got a big size. Okay. If you want, you can take LTY, line type, how you want, whether you want continuous line, whether you want dotted line, however you want, you can click. But as let us take, I will run this on histogram, and here line type, let us say I will 2, I will give my friend this one. Now see, just randomly I'm giving some numbers. There are different types of line types are there and size is there. Just give one number, the corresponding types will get. See, dotted line. Let us take, I will go with size is very big. Let's go with 3. I will draw again histogram. Then line type I will give to, let us take line type with this type 5. Then yeah, power is okay with it. Yeah, fine. See here, I have given line type is 5, some number, and the line with size is 3. I will run this one. This time little bigger dashes I got. So now if you want to zoom it, you can see the zoom values of this one. Yeah, now we can check that data is almost normal. Left side little code is there. No issues. Okay, we can go with this. The assumption of data is following normal distribution. Okay, and if you want to export, you can export this one. So this is the way of we can draw the histograms. Now see the diagrams, how beautiful is that. If you see here, may not be feel that much, but if you go here, if you zoom this one, see how much is good one. People will like these diagrams. Yeah, fine. And if you want to you see the breaks, the histogram bars, the bars are, if you want to give more number of breaks, if you want to give, you can increase that also. That is also I will show you here. Breaks. All the arguments I'm using in one line, that is histogram only. Okay. Breaks equal to, let us say I want 10 breaks. Breaks is nothing but the bars. Okay. Run this one. Now we got the same by default. We got this one. Let us say I will increase the breaks 15. Yeah, see, now see this one. uh Increase the size. See here, how many breaks are there? There are small, I mean, breaks are the bins. We have divided the many bins. Okay. If you increase the number of bins, no, then there is a problem. That is that we cannot identify the normality. We will lose the normality assumption. I mean, normality we cannot get. See, if I increase here, I increase the bins. See, now the normality, now normal curve, how it will come? See, if I draw this one normal curve, I will run this one. See now, it's slowly bending, bending to bending again. Our stop is going again. If I increase the number of bins, it will go in again scatteredness. So when the scatteredness is more, we cannot find the normality. And also, if we have less number of bins, no, for example, let us take, I will give 6 or 8 bins. I will give. Then you can see this again. See, it's showing now almost normal. When the bins are very less, almost the all data points will come closer, and you may see, you may say that data is normal. And if the number of breaks, that is bins, are very far too much, then normality we will lose. We cannot get the decision about the normality. So by for that, you don't change the breaks option. Okay, breaks option is available, but don't use. By default, check how many bins are getting and check the normality normal by drawing the normal curve. If it is normal, okay, otherwise no issues. No, sir, here we are not in a particular way of decision. I don't know how to give a proper decisions because of by seeing histogram. Sometimes it is showing normality, sometimes I'm not showing the normal curve. I don't know whether it is right or wrong. Because of normality means it should be exactly bell shape. Sometimes if you, even if you any one side skewed also, it will show normality at the border case. Okay, now I'm not in a I'm not in a situation that to give a proper justification about my data is that is there any way to text the numerical proof? Numerically, can you verify that my data is following normal distribution or not? Like that means, yeah, you can go with the testing of normality using numerical test that is called a Shapiro test. Is one of the best tests to test the normality about your data. Okay, if you want to perform Shapiro test, just enter Shapiro. Yeah, just I have entered three letters. I got this one. See this one. Shapiro.test, which is a test will be useful to test the normality about your data. Okay, just give your data. What is our data? Temperature, right? temp. Yes, just give the data variable name and go for the run. See, Shapiro Wilk normality test. So this is the data. What data? Shapiro Wilk is nothing. He's the author. Okay, don't think too much. Shapiro is the authors who invented this test statistics. Okay, Shapiro Wilk normality test. Data is temperature, and this is a Wilk test value. So this is we have formula to calculate the normal test statistics. Maybe this may much not required for you people, and you can go with this p value. It is one of the key one. You now in the next class, next tomorrow on classes also tomorrow onwards we'll go for the testing. No, so whenever we are going for testing and you are applying statistical techniques, so almost all decisions depends on the p values. Based on the p values only, you have to give a clarifications, you have to give a justifications, you have to give decisions. So what is this p value? So p value is nothing but it is a probability value which lies between 0 to 1. We know probability is always lies between 0 to 1. And in statistics, p-value is a evidence to say, to give the decision whether I want to take this decision or not. So it is an evidence for us. Okay. Before going to take this, take the decision about this test using the p-value. So if you want to give a decision about the p-value, then again you have to learn one more concept, that testing of hypothesis. We have a statistical inference one theory. In that theory is divided into two concepts. One is theory of estimation, other one is testing of hypothesis. That I will tell you, I will show you tomorrow with some PPT. Oh, what is this one? Okay, so the statistical inference is divided into two types. One is the theory of estimation, other one is testing of hypothesis. In the testing of hypothesis, we have statements, null hypothesis. Maybe one or two persons you have listened this word, hypothesis. So there are two types again, null hypothesis and alternative hypothesis. If you define a positive statement about your data, that is null hypothesis, and alternative to the positive statement, it is called an alternative hypothesis. Generally we will define. Okay, for example, I am not touching that much on this because of, you may think, you may feel that too much statistics are saying. Okay. See, generally in this test statistics, we will define the null hypothesis that what you were saying, testing normal, right? So we can define the null hypothesis that data follows normal distribution. Okay, data is following normal distribution. That is my positive statement I have taken. First initially I have taken one statement that data is following normal distribution. It is null hypothesis. And alternative to this one, alternative hypothesis, data is not following normal distribution. Now use the p-value. Here, what is the p-value we have? P-value is 0.009319. Okay. Now, here one criteria is that if the p-value is less than 0.05, that is 0.05 is a 5% level of significance we will call. Here, one more concept, level of significance. What is this level of significance? Is nothing but level of significance is nothing but we can say that it is a percentage of errors we are allowing while doing our testing. For example, if I'm taking 5% error, 5% relaxation or 5% errors I'm allowing is nothing but remaining 95% confidence. I'm saying that my data results are correct. You can follow 1% level of significance also, which means that 99% I can proudly say that my data techniques are correct. What I got the values, because of almost all statistical techniques will works under some assumption. Assumptions are all non always not correct, right? Just if you're assuming only, based on the assumption you are going for test statistics. Okay, so these assumptions if changes, your results will change. That's why almost all statistical techniques will have some assumptions, so assumptions will be changes according to the situation. That's why we cannot say that 100% statistical techniques are working very well and results are giving 100% correctly. So nowhere we will say that statisticians 100% these results are correct. We will give some percentage. By default, we'll go with 5% level of significance, which means that 95% confidence we can give that my test results, my data results, or my data analysis techniques results are correct. 95% confidence I can give. Rest 5% there may be an error. Okay, so that's why here I'm saying that 0.05. 0.05 is a cutoff value or a criteria to take a decision about our test null hypothesis. Okay, now see if the p-value is less than 0.05, whenever you got the p-value, you can take 1% of the size, 0.01. By default, I'm saying, by default, the people will follow 0.05. If the p-value is less than 0.05, then we can go with the alternate hypothesis. If the p-value is greater than 0.05, we can go with the null hypothesis. This statement you have to remember. That corresponding slide also tomorrow I will show you. But unfortunately, we got the time to discuss, or unfortunately we got the chance to discuss this one. Okay, fine. Tomorrow I will show the PPT also. When the p-value is less than 0.05, you are going with the alternative hypothesis. When the p-value is greater than 0.05, so it is not a significant. We are going with the alternate, sorry, null hypothesis. Remember, p-value is less than 0.05, reject the null hypothesis. That is, we are going with alternative hypothesis. We are accepting alternative hypothesis. If the p-value is greater than 0.05, we are accepting the null hypothesis, rejecting the alternative hypothesis. This criteria, remember. Okay, it is very, very important. Okay, now see here, if 0.0093, this is almost p-value is 0.05, this is less than 0.05, right? 0.009, right? It is 0.009 is nothing but 0.05. It is less than only, right? See, if the obtained p-value is less than 0.05, what is the decision? We are going with alternative hypothesis. That is, we are rejecting the null hypothesis. What is the null hypothesis in this case? What is our assumption? The data is following normal distribution. That is our null hypothesis statement here. Now, what we are saying, what we are doing here, we are going with the alternative hypothesis. That is, we are rejecting the null hypothesis, which means that data is not normal. See, by looking this histogram, we are saying that data is normal somewhat, but actually with going with the numerical proof, the data is not normal. Data is not a normal distribution, it is a skewed distribution. Either may be exponential, either may be a gamma, either may be variable, either may be half normal, either different non-normal distributions are there. It is not a normal distribution. I hope you understand now. So histogram will be useful to test the normality, but if it is exactly bell shape, it is not skewed any one side, then we can say that it is a normal distribution. If you have any doubt about your histogram to take the decisions, then we can go for numerical proof. You can check the numerical proof using, there are different techniques are there. Again, testing normality. That is Sheffield tests are there. Anderson Darling AD tests are there. Jark Bera test is there. Kolmogorov, Smirnov tests are there. There are a lot of techniques are available to test the normality. Mainly, we will go with Shapiro. That's why I'm teaching here. Shapiro test. If you go for the going search in Google about the test of normality in R, you will get a list of techniques. Among that, they will show you mainly Shapiro test, Jork Bera. One test is there. I will try. If you want, note down here. Jork Bera. No, Jork dot Bera dot test. These are tests you can use. Otherwise, you can use one more thing. Anderson AD dot test. Uh, I will give one more hint also. If you want to use this Jark Bera test, we need the package is called a T series. T series package is required. Use this install this T series package. Then Jark Bera test will be useful. Anderson Darling test also by default. NOR test, normality test. We need to use this package. NOR test. So these are the two packages are required to run these functions. One is Jark Bera and AD test. Both the tests are also useful to test the normality only. Why I didn't teach this nothing, but this is required to install the package. No, again we need to go for installation of the packages, and again, so I'm not going much reason. So just simply I will go with Shapiro test. This does not require any package. Why? Because by default we have mass package that is installed in the R programming language. So we don't want to worry about it. So directly we can access this command Shapiro.test. Now using this Shapiro Wilks test, I got the decision is that my p-value, the probability value is less than 0.05. So I'm going with an alternative hypothesis that the data is not following normal distribution. So this data is not normal distribution. Again, so to apply performing any statistical technique, there will be some problem. Why? Because most of the techniques are depends on the normality assumption. In situation, we can go for non-parametric also. Otherwise, we can go one more situation. We can transform this data into normal. Non-normal distributions can be non-normal data can be transformed into normal data by using some transformation techniques. You can use log transformations, reciprocal transformations, square root transformations. Like that, we can use many transformation techniques to transform or to convert non-normal data into normal, so that we can go for normal statistical test. Okay, this is one thing. Histogram. Uh, 420 only, right? Yeah, fine. This is histogram. Now, one more thing I will show you to test the normality using graphs. Have you listened this about box plot? I will draw box plot. Again, same temperature. This is also one of the graphical plot diagram which will be useful to test the normality, and we can see what is the first quartile value, second quartile value, what is the median value, what is the lowest value, what is the highest value, and one more thing we can identify outliers. We know, right, outliers. So outliers also we can identify using box plot. Many people will say that outliers and extreme values are almost similar. Yes, it's similar only, but there is small difference between outliers and extreme values. Generally, extreme values are nothing but these are the values which are far from the original data, but along with that far, they have similar pattern. Okay, let us say in the class, I will take student marks. Let us say student marks, if I connect the examination for 100 marks, 0 to 100 is a range. Now, some students scored 0 marks, one or two candidates scored 99 marks. Now, see, most of the students are scored in the middle, 50, 60, 70, like that. These are the original data pattern. Now, if we take any one student who scored 99, is an extreme case. If I take the student who scored 0 marks, it is an extreme case. This is okay, but it is in the range, within the range. Let us say while entering the marks in any one portal, as a faculty, I wrongly entered, instead of 20 marks per student, I have entered 200. Now see, examination is conducted for 100 marks only, but the value I have given 200. It is an extra. It is not an extra. It is a far only, but it is not in the original pattern. That is, it is not in the original range. Then now the 200 value is nothing but outlier, which is not in the range of the data, which is not following original data pattern. Okay, so that outliers we can identify using box plot. So using box plot we can identify, we can test the normality as well as we can identify the outliers. So extreme values or outliers, just keep in mind. Okay, many people will get confused. Extreme points are nothing but it is far points but within the range which follow the same pattern of the original data. Outliers are also far from the original data but doesn't have any pattern, doesn't follow any original data pattern, or which are not in the range. Okay, that outliers we can identify. So sir, what is this, what is the why we want to identify outliers, and what is the main mode of this outlier, main concept of this outliers is nothing but whenever we have outliers in the data, no, mean will not affect, mean will not be worthy. Why? Because mean is very sensitive to the outliers. If you have outliers, mean is not possible to measure, to find the central tendency. Okay, why? Because let us say 1 2 3, what is the mean? 2. If I have any one value, let us say 1 2 3 50. 50 is a very far extreme case. Then if you find the mean will changes to middle. It will go to 20 50 like that. So mean will be highly affected with these outliers, that we have to focus more. So either you have to remove the outliers, again we have to replace that outliers with some measures. Okay, that I will show you how to draw this box plot. Yeah, yes, we got. We'll give some color. It should be good. Color equal to some green. I will give. This is okay. Sir, some more time, sir. We'll finish this one. Yeah. See, this is the box plot. So this box plot tells us. So below is a lower value, lower whisker, and above is the upper whisker. Okay, these two we will call the whiskers. So minimum value, maximum value, and this box will tells us where the data points are morely scattered around. See here, if I take this one from here, this is nothing but 85, and if I take this one here above 70, so most of the data points are scattered in this region, and this is a maximum value and this is the lowest value. And here the coming to the box, the below line, this box below border is this will show the first quartile, the 25th percentile value, and this will have the third quartile, 75th percentile quarter value, this third quartile. So first quartile and third quartile, and the middle one is called a median. We know median, right? Median is the center value which divides the data into two parts, right? So median value, this bold color. Okay, so first quartile, second quartile, that is median, and third quartile, it is a highest value, maximum, and this is a minimum value. And here you can see this one. If the data, if you want to claim that the data is following normal distribution, then this median value, the middle value should be, so the middle thick line is there, no, this value should be in the middle of the box exactly. But here you can see one side it is closed, upper side the middle line is closed. If this middle line is exactly in the center position of the box, then we can say that the data is following normal distribution exactly. That easily we can claim. And if you have any outliers, as of now here we did not get any outliers. If you have an outliers, no, here you will get a one dots. I will show you, I will add one point. Let us take range of data, range of temperature. What is the range of temperature? 56 to 97. That is what we got. See here, 60 below, 56 somewhat, and this is above. What is this above? Around 96 and 97. This is a range. I said no, minimum value and maximum value. Let us take, I will give one value. Temperature, let us take C of TEMP. Temperature is original data. I will give one value. Let us say that value will be 150. Let us say I will give one big value, which is an outlier of the data, which is not in the near to the range. It I'm giving very far value 150. This I'm creating outlier. Okay. Now I will take this entire data, copy. Now instead of this temperature, I will give this one. C of temperature comma 150, which means that temperature values are there along with add one more value. Concatenation, right? And now I will draw this. Now see here. I will lose. See here. This is outlier. So outliers will be shown either above side or below side. If the outliers are lower to the minimum value, then it will come here. If it is above, it will come here. See, this is an outlier. Now with this outlier, for if I take all the data points mean will be highly affected. I will show you that also. For example, if you want to find the mean of the data, so what we'll use the command mean, that is TEMP, temperature, right? What is the mean? 77.88. Now, for example, let us say find the mean of this data set, the newly added data point 150. See, data is, oh, great. It is very slightly affected. Let's go with one more. I will give 250, 350, 79. Oh God, it's slightly changing. Fine. Uh, Generally, mean will be affected by the outliers. It is here we have only one outlier, maybe that because of that one. Otherwise, I will give one more outlier, 150. Yeah, it's changing. Yeah, fine. So this generally this mean will be highly affected by the outliers in the data. So that's why I'm saying that. So if we have any outliers in the data, so we that outliers easily we can identify using our box plot. Okay. Yeah, fine. This is box plot. One more thing I will show you one. Sir, shall I continue?
Yeah, okay, no need, sir. Tomorrow we can, sir, because time.
Ah, okay, fine, sir.
Yeah, she was at
Okay,
noon.
so tomorrow we'll go with this is actually I have created only small simple graphs. One is histogram box plot for continuous data, and this is for discrete data. That is pie diagram and then bar plot. Okay, tomorrow we'll go with two-dimensional. This is a generally one-dimensional diagrams, only one variable. We'll go with two-dimensional diagrams. Two variables will take and how to draw these scatter diagrams, matrix scatter diagrams. All these things we will discuss. Three dimensions, three diagrams, and EDA, expert data analysis, we will discuss. Yeah, fine. Sir, if you have any doubts, you can ask.
Yeah, I think
I'm
someone
going
has.
very fast. I understand it. Why? Because I want to cover more. That's why I'm saying this much. If you
Okay, no
have any
problem.
doubts, you can ask.
Tanu
I
Tyagi, I
will
think,
save this.
sir, one doubt
Sir?
in chat box, one of them has raised the doubt.
Yeah, I will. I will go back. So today voice is clear, no?
Yeah, very clear and perfect.
Yeah, good. Nice. Thank you.
In chat box.
It's, wait, sir. It's not opening for me. It got stuck. Wait, sir. It's got stuck for me. I don't know what is happening.
No, I will tell no problem. Histogram code is not running. It gives error on running.
Yes, I got. Wait, sir. Sir, Instagram code is not running. It gives error on running. Madam, can I know what is the Tanu Tegi? Yeah, madam, can I know what is the error you're getting? Or can you share with me? You can present your code. I will look at it.
Yeah, Tanu Tyagi, ma'am. I think you are on.
You can share your screen also, ma'am.
Yeah.
Available or not?
I think she is not there.
No, no, no. She is there, but she is not responding.
Not responding.
Uh,
Okay, I think anyone other doubts regarding today's session?
so
Yeah,
box
please
plot
continue.
temperature month data air quality. Box plot temperature tilde month data air quality light bulb main temperature by minute x value range. Ma'am, this code is wrong, right? Box plot. What is this temperature dollar month? From where you got this code, ma'am? May I know what is what you are going to show here? Main is okay, ma'am, and color is also okay. Whether the light bulb is color is available or not in the R program, you can verify because once you type this light bulb, automatically if it is available, the color will change. And main is okay. X lab Y lab does not require, ma'am. Why? Because X label Y labels is right. Box plot does not take X lab Y lab, right? Box lab will come only in one axis, that is Y axis only. So maybe this X lab Y lab does not require. And then box plot is a only one dimension diagram, not a two-dimension diagram. Here you have given two variables. Box plot within the parentheses, within the I mean in place of data, you have given temperature tilde month. Temperature tilde month means whether you are drawing multiple box plots or a single box plot. If it is single box plot, go with only any one variable. Then if you are going with multiple box plots, then we have to verify this one, ma'am. Then okay, fine. Then temperature according to the month wise you will get. Am I right? It's like a uh, so multiple bar diagram. Like that you will get multiple boxes. What happened? Is it working or not? Madam is giving a reply yes. Whether it's working or not. It's not
Yeah.
working. Just a minute, ma'am. I will copy this one. I will load into my R. I will show you. Ma'am, it's working for me. I don't know what's the problem to you. Sure, I will share my screen, ma'am. Just I copied your code and I pasted. That's it. My screen is visible, right?
Yeah, visible, sir.
Yeah, fine. Here you see, ma'am. Just what the code you have given. Just I copied and pasted. Yeah, it's working. Temperature by month. See, this is multiple box plot diagrams. See, box plot. This is according to month wise. First, let us say there are 12 months data, right? We have 153 observations. In that 150 temperatures are there. 111 is represent January, 255 represent May, like that we have data. So according to the month wise, the madam has displayed the box plot, tested the normality. Okay. Now see, this one is 5th month. This is 6th month, 7th month, 8th and 9th month. There are only these 5 months data is only available. Yesterday we have seen the data also, so from May to September. Okay, so May to September data set is available. So every data set, what is the temperature distribution? Okay, see, almost all the variables are not following normal distribution because of the center line is not in the center position. And then in the 6th month and 7th month, if you take separate, if you take the category wise data, 6 months, 7 months is having some missing, outliers. In 7th month, we have 2 outliers. Here it is running, ma'am. You can verify whether what is the problem. Now it's working, sir. Okay, fine. Any other doubts, sir? Madam, you asked the histogram code is not running. It gives an error on running. Is it working, ma'am?
Yeah, she is replied.
Yeah,
Yes,
yes,
now it's
sir.
working.
Now working. Thank you, ma'am. Any other doubts? If you have, you can raise.
Okay, no one doubts. We can wind up for today, sir. Thank you.
Yes, yes, fine, sir. Sir, your understanding, right? I'm going with little fast. Why? Because I don't know whether what's there outside. I am not seeing the participants there.
Yeah.
Just I'm going with my flow.
Shiva sir,
Sir,
today no problem, sir. Everything is clear.
okay, fine, sir. Thank you, sir. Maybe internet issues, sir.
Yeah,
Today
you
I
have changed
requested
the
them.
system or you followed the same
Yes,
system?
sir.
Okay, okay. And I asked
Thank
the
you,
same,
sir.
sir. You don't forget. You forget that
Yeah,
one.